Let's look at some equations that are actually quadratic in form. They don't appear to be quadratic when you first see them, and we're going to use some things that you learned in other modules for how to solve these. So it says, recall from Module 3, when solving rational equations, you must find and use the LCD. So when I look at this equation, 1 over x plus 1 over x minus 1 equals 7/12, the first thing that I have to do is get rid of those denominators, get rid of the fraction by using the LCD. So the LCD has to represent each denominator present, so I need a 12x and an x minus 1. I need all three. So what I'm going to do is I'm going to rewrite these so we have a little bit more space. And I'm going to put each term in parentheses, and I'm going to multiply, I'm going to have to sort of stack them up, by the LCD. When you don't have room, you just stack them up and know that they really are in a numerator over 1. And now each of my denominators will cross cancel. So x cross cancels x, and you're left with 12 times 1 times x minus 1. So 12 times x minus 1. This term, x minus 1's cross cancel, and I'm left with 1 times 12x, so it's plus 1 times 12x. Here, the 12's cross cancel, and I'm left with 7 times x minus 1. Now at this point it's almost difficult to see what we have, so we're going to go ahead and distribute in these two instances and see what we've got. So 12x minus 12 plus 12x equals 7x squared minus 7x. I'm going to combine like terms here. 24x minus 12 equals 7x squared minus 7x, and as soon as you see that squared term, you know that it's quadratic. So we've talked about a lot of different ways to solve a quadratic, but in this case, not knowing for sure what we have, we're going to get it equal to 0. That's always a good rule of thumb. So I'm going to subtract the 24x. Negative 12 equals 7x squared minus 31x. Now I'm going to add the 12 to both sides. And that gives me 7x squared minus 31x plus 12 equals 0. Notice I switched sides to get that 0 on the right. Not necessary, it's just a habit that I have. Now, this is not a good candidate for square root property because it's not in the right format. It's not a good candidate for complete the square because there's not a 1 in front of the squared term, and this is odd. So I'm either going to use the quadratic formula or I'm going to factor. I'm going to check factoring first. So I'm going to say long process 7 times positive 12 is positive 84. I need factors that add up to negative 31. Not knowing what they are and worrying about the signs at the end, I'm going to start with 84 times 1, divide by 2, multiply by 2, 42 times 2, divide by 2, multiply by 2. Now I can't divide by 2, so I'm going to bump up to 3. Divide 21 by 3, multiply by 3. I'm going to continue, divide 12, it's the bigger number now, by 2, multiply by 2. We're looking to see if anything is going to add up to 31, and so far we don't have anything. So if I divide the 14 by 2, it takes me back to the 7. So I'm going to divide the 6 by 2, multiply this by 2, and there is a way that I can get 31. Now we figure out the signs. To get a positive 84, I need a positive times a positive or a negative times a negative. That's the only choices you have. But for this to be a negative 31, that means I need 2 negatives. So now we break down the 31x into negative 28x minus 3x. We're breaking this down. Bring down the last one. We now have 4 terms, so we're going to group The minus here says make a correction on my last term, and I'm now going to factor out the GCF of each. So I have 7x times x minus 4, bring down your minus sign, 3 times x minus 4 equals 0. These match, so x minus 4 is my first factor, 7x minus 3 is my second factor. So it was factorable. Now at this point, I'm applying the zero factor property, and I'm going to say either x minus 4 equals 0 or 7x minus 3 equals 0. Solve those two equations. I get x equals 4 as my first answer. Here I'm going to divide now by 7, and I get x equals 3/7 as my second solution. It's not necessary in this case to check those two because I didn't square anything. Only when you square, when you have a radical present and you square to get rid of it, do you have to check. So if I did my algebra correctly, and I did, then we know that these two solutions will work. All right, another review to prior material is these next two when solving radical equations. So it says when solving radical equations, you must isolate the radical and square both sides. So we're going to do that, and you're going to see that this time we are going to get quadratic equations. So in example 2a, the radical is already isolated, so I can go ahead and square it, square the other side, and I get x squared equals 6x minus 8. Because of my squared term, I'm going to go ahead and get, I'm going to subtract the 6x. I have x squared minus 6x equals negative 8. Now at this point I have a choice. I can add an 8 to both sides, get it equal to 0, and attempt to factor, or I can complete the square. Because I have a 1 in front of the squared term and an even middle coefficient, I'm going to complete the square because I think it's going to be easier. So I'm going to take that middle coefficient, divide it by 2, circle that, square it, and I'm going to add a 9 to both sides. That's that magic number that we talked about before. By doing that, I forced the left-hand side into being a perfect square. And this tells me what it is. It's x minus 3 squared. If you factor that, that's what you get. Equals 1. Now I apply the square root property, and I get x minus 3 equals plus or minus 1, and this is where we split it into two pieces. X minus 3 equals positive 1, x minus 3 equals negative 1. Solve each of those, and I get x equals 4, maybe. Add a 3, and I get x equals 2. Now, because we squared in order to solve, I have to check both of these. So let's check the 4 first. That would be, and I'm kind of out of space, so let's do it on another sheet. I'll lay it right here. Let's check 4. So that would be, does 4 equal the square root of 6 times 4 minus 8? Does 4 equal the square root of 24 minus 8? Does 4 equal the square root of 16? And it does. Now we want to check. Our other answer was 2. Does 2 equal the square root of 6 times 2 minus 8? I just put it back into my original equation. Does 2 equal the square root of 12 minus 8? Does 2 equal the square root of 4? Yes, it does. So in this particular case, both of our answers did check. All right, let's look at this second one. In order to solve this, I have to isolate this radical. So I'm going to subtract the x. That gives me square root of x equals 6 minus x. Now I'm going to square both sides. So x equals, if you FOIL this out, write it twice, and FOIL it out like this, you're going to get 36 minus 12x plus x squared. I'm going to subtract an x. Now I'm going to write it in a different order. I want the x squared first. That's going to be minus 13x plus 36 equals 0. This is not a good candidate for complete the square because it has a middle term that is odd. So I'm going to factor. Positive 36, I want two factors that multiply to make that, but they add to make negative 13. And I think those are negative 9 and negative 4. I'm kind of off the side of the page here. There you go. So that gives me x minus 9, x minus 4 equals 0. Using the zero factor property, either x minus 9 equals 0 or x minus 4 equals 0. Solving those two by adding a 9 here and adding a 4 here, I have two possible solutions. But once again, we're going to check those, 9 and 4 in our original equation. So let's check 9 in that equation. So does 9 plus square root of 9 equal 6? Well, you can already see that that is not going to work. So 9 doesn't work. So I'm going to go back here and discard 9, which means the 4 has to work. But let's just verify that. So does 4 plus square root of 4 equal 6? Does 4 plus 2 equal 6? Yes, it does. So I know that one of the answers worked and one of them did not.